Oompa Loompa, Doompa-dee-doo. I've got another puzzle for you. Oompa Loompa, Doompa-dee-dee. If you are wise.
Alright everybody, welcome to the 5-3 notes on solving polynomial equations, and more importantly, welcome to my house. Hope you like what we've done with the place. It's just a joke for those of you that don't get it, because if you can actually see my house right now, that's really weird. Alright, so we're going to take a look at Chapter 5, Section 3 today, solving polynomial equations. There's a bunch of different ways we can do this. We've learned a lot of them in other units, and so now we're going to apply them to this. So we're mostly going to look at factoring and graphing, but there's all sorts of factoring things that we know how to do. So what we have to understand and remember is that if x minus a, this part right here, if that's a factor of a polynomial, then the polynomial has a value of 0 when x equals a. That's the zero product property stuff, okay? So really simply, solving a polynomial using its factors, real or imaginary, okay, real or imaginary on this one, based on the directions. We look at this problem and we have 2x cubed minus 5x squared equals 3x, so we know that we always want to set it equal to 0. We always want to set equal to 0 before we start solving. You should recognize that there's a greatest common factor, so you factor that out. Then we try to factor this 2x squared minus 5x minus 3. And we get this. We set each one of those equal to 0, so the solutions of that polynomial equation are 0, -1/2, and 3. Okay? Not really complicated, just applying some stuff we've previously done. Here, same kind of problem. Right here, since we're just solving, we're not graphing, we notice that there's a 3, a 6, and a 12, and all of those are divisible by 3. So the book says they multiplied both sides by 1/3. We're just solving, so we don't really need the coefficient there if we can get rid of it, and here we can. I would have divided both sides by 3, but multiplying by 1/3 is the same exact thing. So we do that, and then we have a much simpler polynomial. We factor out an x squared, and then here, this doesn't factor, so we use the quadratic formula, okay? We use the quadratic formula right here. We substitute in because we have some imaginary solutions, okay? The solutions here are 0, 1 plus I times the square root of 3, and 1 minus I times the square root of 3. So those are the solutions here. Do me a favor, go ahead and pause the video right here. I need you to try, got it, number 1. I need you to try 1A and 1B and get some solutions, real or imaginary, for those problems. So go ahead and pause it right here and get some answers. Alright, on 1A, the solutions I got were plus or minus 1 and plus or minus 2i. On 1B, the solutions I got were 0, 2, and 3. I'll give you some hints, and then if you have questions on these, you can ask in the comments on the YouTube channel, or you can tweet me questions and I'll give you specific answers, or email, of course, too. This one's already factored for you, so then I'm just setting each one of these equal to 0. This one factors. This one I use the quadratic formula, so there's some hints there. This, I got to make sure that I set everything equal to 0, and then I'm looking for a greatest common factor. Once I have the greatest common factor, this one factored pretty easily. Okay, so there's the hints on that one. If you still need help, like I said, ask in the comments below the video, tweet me, email me, send a smoke signal, do something. Alright, let's take a look at polynomial factoring techniques. So these are all things that we have done before and some examples of them, so just some things to keep in mind. So factoring out GCF, we just did that. Quadratic trinomials, we just did that. Perfect square trinomials, that was our special case. Here's the other special case, which is difference of squares. We can factor by grouping. We haven't done a lot of that in this class, but factoring by grouping is something that we can also do. For example, here, these two have a greatest common factor and these two have a greatest common factor. When I factor those out, I'm left with x plus 2 and x plus 2. Factoring by grouping we did in Algebra 1, and you'll remember that when you do it correctly, the same thing appears twice if it's a problem that you can factor by grouping. And then here's a new thing. It's called the sum or difference of cubes. So if I have two cubes, a cubed plus b cubed, or a cubed minus b cubed, it factors out very neatly into this formula, okay? And we're going to talk about ways to, how to do that and look at some examples. But if you just looked right here, 8x cubed plus 1, that factors into 2x plus 1 times 4x squared minus 2x plus 1. If we had 8x cubed minus 1, and this is a cube and that is a cube, so it's a sum, this is difference, and then this just factors out to that. I know, for example, one way that some people remember it is with the acronym SOAP. Yikes, that's not SOAP, guys. So SOAP, so if we have the sum of cubes and it's the same sign, the opposite sign, and then always positive, so same, opposite, always positive. And down here again, same, opposite, always positive. So that's a way of remembering it. Let's take a look here. The sum and difference of cubes is a new factoring technique. Here's why it works. If we're factoring a cubed plus b cubed, we can say that a plus b, so this is same, opposite, always positive. So what we have is, we have a cubed plus a squared b minus a squared b minus ab squared plus ab squared plus b cubed. That's just if we take this binomial and multiply it by that trinomial. If we do that, the result, when we factor out an a squared from this first term, and then minus ab times a plus b squared times a plus b, and then we factor out again, we're left with just this, okay? So it's just proving that this does work. This isn't like a trick or anything like that, but it works every time. So again, I would just concentrate on trying to remember SOAP or some other method of remembering how to do that. Okay, problem number 2, solving polynomial equations by factoring. So what are the real or imaginary solutions of each equation? So again, we're just factoring. We have x to the 4th minus 3x squared minus 4. So sometimes, you know, people like to take something that's complicated out and put in something that's a little bit easier. So if we take x to the 4th out, we're really good at factoring binomials, but quadrinomials, we're really good at factoring quadratics, okay? But quartic functions is a little bit different, right? So some people substitute, you know, let's take out x to the 4th and put in a squared. I think this concept of substituting a variable in for a variable is complicated. Whereas if we can just look at, to get x to the 4th, the easiest way is x squared times x squared. Okay? They do that, and then they factor, and then they substitute the x squared back in. Again, I think that's a step that we don't need to take, to be totally honest. Here we get x plus 2 times x minus 2, and then x squared plus 1 equals 0. We do need to solve for all of the roots. It follows from the zero product property that x equals 2, so that one we got x equals negative 2, and that x squared equals negative 1. When we solve x squared for negative 1, we need to know that that's going to be I or negative I. Okay, so those are our potential solutions there. We graph that function. It shows roots here and here. This means that there are 2 imaginary roots which do not appear on the graph because it only has 2 intersections. Okay, so we can check these in our graphing calculator. We'll talk a little bit more about that. Example B has x cubed equals 1, so we subtract 1 from both sides to get it equals 0, and then we realize that x cubed is a cube and 1 is a cube, so our difference of cubes factoring technique works. So we have same, opposite, always positive, and so now we know 1 is a solution, and then we use the quadratic formula to find the other 2 solutions. So we have 1, negative 1/2 plus I times the square root of 3 over 2, and negative 1/2 minus I times the square root of 3 over 2. So all that stuff we did with complex numbers, factoring, all that's coming back now for us to use. Okay, so let's take a look here and see what we can do. So go ahead and pause the video here, see if you can get some answers to 2A, 2B, and 2C, and then unpause the video. Alright, so here are the answers I got. I got plus or minus 2 and plus or minus 2I for the first one. I got x cubed equal, for the solutions here on this x cubed one, I got 0, negative 4, and 2. And here I got 2, negative 1, and plus or minus I times the square root of 3. Okay, again, same as before. If you have questions on any of these, feel free to comment in the, put a question in the comments below, tweet me a question or email, okay, and I'll help you out with those. While factoring is an effective way to solve a polynomial equation, you can always find the real roots quickly by using a graphing calculator. So if this were a graphing calculator question, really simply what we can do is, well, we can do two things. Here, if we're given an equation that looks like this, we could graph them both. Okay, so we could graph x cubed plus 5, and then we could graph 4x squared plus x, and we could find the intersection. Another way to do it would be just to rewrite it, setting it equal to 0, and then find the zeros of the function. So you can do either way. You could look at this as two totally separate graphs and then look for the intersection, or you could move everything over to one side, set it equal to 0, and then find the roots. I think that students are more successful with method 2, simply because sometimes finding that intersection when they're really close like this or like this, that can be difficult, especially on a TI. So I think you're better off getting everything, set it equal to 0, and then finding the roots or the zeros of a function. Let's go ahead and do that for number 3. What are the real solutions? Real, so no imaginary this time. So this is just in the calculator. What are the real solutions of the equation x cubed plus x squared equals x minus 1? Go ahead and pause the video and do that right now. Alright, so for the answer for part A, I got negative 1.84. If you round it differently, no big deal. For part B, I still think it's the second method. I think that it's more reliable. It's easier to find the zeros. And sometimes finding the intersection can be a complicated thing in a tight spot. Alright, so now modeling a problem situation. Close friends Stacy, Una, and Amir were all born on July 4th. Stacy's 1 year younger than Una. Una is 2 years younger than Amir. On July 4th, 2010, the product of their ages was 2,300 more than the sum of their ages. How old was each friend on that day? Okay, so this is just coming up with the equation. Here we have the sum of their ages, x, x minus 1, and x plus 2. So we add those up. And then it's plus 2,300. And that's equal to, because it says it's 2,300 more, than the product of their ages. So now it just becomes setting it equal to 0, graphing it, and then finding the 0 of the function. Here we get that it's 13, so there were 13, 12, and 15. Not a very complicated problem if we can get the setup. Okay, so now let's take a look at number 4. What are 3 consecutive integers whose product is 480 more than their sum? So we need 3 consecutive integers first. So this we can use x, x plus 1, and x plus 2. Okay, their product is 480 more than their sum. Okay, their product is 480 more than their sum. So if we add 480 to their sum, then we will get their product. Okay, so I'm helping you out on this one. I'm giving you the setup. There's the setup. Pause the video right here. You get the answer from me. All right, hopefully the answer you got there was 7, 8, and 9. Okay, 7, 8, and 9. And that's it for this video, guys. Hopefully this was a nice little short video for you. If you had questions on those problems, by the way, I really need you to ask me questions, hopefully before you get to class, so we're not overwhelmed with questions when we get back. The 5-4 notes will be up soon also, so you'll be able to get started on those. Hope you guys are enjoying your break. I'm going to go make a cup of hot cocoa and watch Home Alone 2 for the 78th time. See you guys next time. Bye.
Who do you play when your kid is up? Rat, pampered and spoiled like a Siamese cat. Blaming the kids is a lie and a shame. You know exactly who's to blame. The mother and the father.